Hello, class and other random internet people. I wanted to kind of quickly talk about an earthquake that occurred about 24 hours ago on February 8th, 2025, that occurred down here in the Caribbean. It was a 7.6 on the Richter scale. I'm going to zoom in down here in the Caribbean, and it's that little blue one right there. Why is this significant? This is one of the largest earthquakes on planet Earth in the last couple of years, so it's a pretty big one. There was a tsunami warning that went out because of this. That has long since passed, and there's no concern anymore. But let's talk about what's going on with this and why there wasn't a tsunami, and maybe a little bit why sometimes there are tsunamis with earthquakes. So you can even see right here, there's all these other little dots. So these are all little, likely aftershocks that occurred after the fact. And some of these are fairly large in their own right. 4.8, 4.2, 4.8, 4.6, 4.3. But let's look mainly at this one. So 7.6, and it was only at 10 kilometers depth. So like, what is that, like 6 miles? That's pretty shallow. When an earthquake is that shallow, you get pretty worried about tsunamis. Sometimes they'll be, around 40, 50 kilometers at depth, and those deeper ones have less of a chance of producing a really bad tsunami, just because there's a lot of rock up above it that kind of gives into some of that squishing. So what happened here? Why was there no tsunami? Well, we can take a look at the tectonic plates in the area. This earthquake kind of occurred over here just to the west of Jamaica. You can see Jamaica right there, and there's this little zigzag on this line, which I'll talk about in a second. And we can see that same zigzag right here. So this earthquake occurred right here along this Walton Fault Zone. This Walton Fault Zone is a strike-slip fault. That means the stuff on one side is going one way and the stuff on the other side is going another way. The good news about this, and what typically causes earthquakes, is where, or what typically causes tsunamis, is where plates or faults are coming together. Here's the three basic types of faults. You have a normal fault where they're actually being pulled apart, where one thing is kind of dropping down, the other thing is going up. So you have extension, like the shown here on this little diagram. Compression is the one you want to worry about in terms of tsunamis, where you have something getting pushed up. And that has a high likelihood of generating tsunamis, and has definitely done it in the past. But the fault we have here is a strike-slip fault. Things are just going side by side past each other, and there's nothing really getting pushed up. It's when you push that seafloor up with a thrust fault or reverse fault that is a problem, because when all that rock pushes up, you're pushing up all the water on top of it and generating a tsunami. This is kind of what that looks like. So you have plates coming together here, you've got compression here, and eventually the stuff on the top will kind of pop up, and it pushes all that water up, and you've created basically a pulse there in the water, and that pulse of energy actually moves out extremely quickly, about as fast as a jet airliner, about 500 miles per hour, or, well, this diagram says 600. And then as it gets to the coast, it'll kind of slow down, and that energy will get focused onto the shoreline, and you can get a large tsunami because of that. But here what happened is you've got this strike-slip fault and not a thrust fault. So that's why the tsunami didn't happen. So what did people feel? So this is a very simple map showing the Mercalli scale, not the Richter scale, Mercalli scale, which is more qualitative. So the Richter scale is all about like the amount of energy that's released at that one point. The Mercalli scale is more of like, what did you feel? So this actually tells me more about, human impacts than the Richter scale will. Technically, I've been in an earthquake that I think was like a 7.5, but it was like 50 miles away or something. And even though it definitely woke me up when I ran outside in my boxers when it was 0 degrees in Anchorage, it still wasn't that bad. There wasn't really any damage, or it was very minor. However, if I had been near that epicenter of that 7.5 or whatever it was, my house might have gotten destroyed. But here, it just kind of shows this Mercalli scale. It's just 1 up to 10 plus. And it kind of, you can look this up, and there's descriptions that go along with each of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But generally it's, you can see here, not felt, weak, light, moderate, very strong, etc. So I'll look at the same. Well, we can just briefly look at this. So we can see the people here in Georgetown and over here in Jamaica didn't feel much. However, there's a little red dot right there I want to talk about. I can show you effectively the same map here. It just roughly estimates that Mercalli scale and what people are going to feel where. Now these little dots, these little squares are where actually people reported. You can go to the USGS website and there's a little like did you feel it map and you can report on it and claim what you felt. Based on the estimates, this person here who reported this said like that was crazy, that was a 9, that was almost as bad as it gets. USGS is like, yeah, probably wasn't that bad, but it's worth going and looking at after the fact. This is just an estimate, and there's a lot of measurements that can be done and looked in more detail after the fact, and maybe maybe it was this bad right there. But you can see it wasn't too bad over here in Georgetown, and then over here in Jamaica and Kingston it wasn't too bad. A little bit more feeling here along the coast of Honduras, but overall not too bad, and especially since there wasn't a tsunami. You can imagine if there was a tsunami generated with this. It's very close to Central America here, and there's a lot of things here that'll go wrong. Huge cruise ports up here. A lot of people in the U.S. go on cruises out of Galveston, and it goes down here to Cancun, and that would be a problem if you had a huge tsunami generated in this area. And again, I mentioned that the energy of a tsunami moves out at 500-600 miles per hour. That would only take an hour or two for a tsunami to reach these areas, so there wouldn't be a whole lot of time to evacuate. Actually, maybe less than an hour. So 50 miles. There's my scale. 50 miles. So yeah, maybe about an hour. Yeah. So that's pretty much the gist of it. But I was kind of curious about this little thing and what's going on right there. And if you get on Google Earth, you'll see that there's a couple of tiny little islands there called the Swan Islands. You can see there's an old airfield, I think, that's across there. And I went and pulled up Google Earth, and it's these Swan Islands, and they're owned by Honduras, and apparently there's all of 10 people there that are just kind of managing the airfield for the military for Honduras. So yeah, population is 10 in 2014, but I'm sure the military pulls and pushes people out of there with some frequency, so who knows how many people are actually there right now. But you can see they probably got on their cell phones or on the computers and kind of reported it. One dude on one side of the island said a 9, the other person said a 6. So kind of cool to have that connection with those guys that are there on the island. And who knows, maybe they'll find this on YouTube. And if you guys do, and you speak English, or if you can understand me, leave a thing in the comments, because that would be hilarious. So yeah, that's what happened. No tsunami, big earthquake. There's going to continue to be these little aftershocks here. Anytime you have a very large earthquake like this, it could potentially set off a lot more. We can, fantastic examples of what happened in Japan in 2011. There was actually a large earthquake that went off, and I think like a day later, the really, really, really large earthquake set off that generated the tsunami over there. And the amount of shaking that happens after that goes on for a long period of time. And you have to remember that these are tectonic plates that are on the move. It's not some just small isolated thing or an explosion underground or anything. You've got immensely large pieces of rock that are moving by each other. And it's massive, massive, massive energy. And once you kind of get that started, a lot of the rest can kind of crumple along. And it's not impossible that this could set off another earthquake that's even larger. However, it's been over 12 hours now, so it'd be a little bit of a surprise if it did, but it's not impossible. This area does have a history of having earthquakes. This isn't that unusual. But I think what the unusual thing would be here is if you had a tsunami. However, I don't want to say that that's impossible. And, we have a nice straight line along here. But in reality, you get in close to these areas, and that line can be a little bit more jagged. And so you can have little spots along faults of transform faults where you have a little bit of compression, and you can get a little bit of that uplift on the ocean floor. So, yeah, so something definitely worth kind of considering. If it were me, and I'm not like an expert. I've worked on some education stuff with this tsunami guys out in Hawaii, so like I've talked a lot about this, but I don't want to pretend like I'm a heavy duty tectonic seismologist that's looking at this stuff. But if I were just a normal citizen living anywhere in these areas, I'd make sure my, I had a go bag. And I'm ready to jump in my car and kind of go inland a little bit, just to be safe. And like I said, you'll have a good hour's notice for when this kind of goes out. So one of these happens, USGS tells everybody about it, and within moments, alarms should be going out about this in a lot of these areas. So that's kind of my little amateur take on the safety of this moving forward. Is I wouldn't worry too much about it, but just in case, I'd be ready to go. And it's something to think about, kind of moving forward if something like this again happens in the future. Of note, I think, is this spreading center right here. This could, in a lot of tectonic settings, you'll have it to where you kind of see a zigzag like this, and this is actually an area of compression, and so you could get a tsunami generated here, but in this case it's not. It's a spreading center, and so it's moving apart, and you have much lower likelihood of large earthquakes happening there that are going to generate tsunamis. So, yeah. If I said anything that you think is wrong, let me know in the comments. I'm not perfect. My expertise is paleontology. But, yeah, let me know. If you have any questions, shoot them in the comments. I'll keep an eye on this for a couple days. And for all my students that are currently my students, be sure you're checking Canvas. It's Sunday. There's a discussion and a quiz and a lab assignment due. So if you're on my online students, be sure to do those. And, yeah, keep an eye on what's due. And if anybody's got any questions, let me know. You know how to get a hold of me. See ya.